Today we'll discuss the properties of the waves. Last time we discussed the types of the waves, that waves can be of two types. So we can have a longitudinal wave or we can have a transverse wave. This is what we discussed in the last class. So a wave can be transverse or it can be longitudinal. So today we'll discuss the properties of longitudinal and transverse waves. So what are the properties of the waves? A wave can reflect, a wave can refract, a wave can diffract, a wave can interfere, and a wave can polarize. These are some properties of the wave, but in O levels, you will only learn three properties. You will learn only about reflection, refraction, and diffraction. Other properties you will not learn in O levels. Now, to study the properties of the wave, what we do, we use a ripple tank. So wave can be transverse, wave can be longitudinal, and these are some properties of the wave: reflection, refraction, or diffraction. But you will an interference, polarization, but you will learn only three properties: reflection, refraction, and diffraction. Now, to study the properties of the wave, okay, you want to take the screenshot, you can take now. So to study the properties of the wave, what we use a ripple tank. What is a ripple tank? A ripple tank, a tank which is filled with water. And why we call that as a ripple tank? Because it's easy to produce the water waves. Like you have a container and it is filled with water. A tank which is filled with water, we call that as a ripple tank. Now, how we can produce a wave? So what we can do, we can take an object here at one end, and if I move this object up and down, when I move this object up and down, what it will produce? It will produce ripples or it will produce waves. So when I move this object up and down, waves are produced. So to study the properties of the wave, we use a ripple tank. Why we use a ripple tank? Because it is easy to produce a wave. The reason for using a ripple tank, because it is easy to produce wave, and the second thing, we can observe easily. Like for example, sound we can produce easily, but we cannot see the sound waves. Light also we can produce easily, but we cannot see the light waves. What happened in ripple tank, we can produce the wave easily as well as we can observe or see them. That's why we use this ripple tank to study the properties of the wave. Is it clear till now? The ripple tank. So if you look at this tank sideways, this is how it appears, like the waves. But if you look from the top view, if you look from the top, it does not appear like this. How it will appear? If this is a tank, a top view, this is a side view. This one when you're looking from the top. So what you see, like example, if I was having a large object, say this was an object which I am moving up and down. So what pattern I will see for the wave? I will see waves are traveling from one place to another. But these are not actually waves. What are these? These are the wave fronts. What is the meaning of the wave front? When I produce a vibration, this is you are looking from the top. So what you will see? You will see this kind of pattern if an object is big. But if object is a small, like example, if you drop a stone into a pond, what you will see, you will, and you're looking from the top. So if I drop the stone in the pond and exactly at the center. So if I drop the stone here at exactly at the center, so what I will observe? I will observe ripples, waves, but these are not actually waves, these are called wave fronts. What is the difference between wave and wave front? When we represent the identical points of the wave, like example, this is one wave, this is another wave, then this is another wave. So when we join the identical point, like crest, crest, and crest. So when I join all the crests together, the line which represent the identical point of the wave, this line is called wave front. Then another crest, second crest of first wave, second crest of second wave, and second crest of third wave, that is also called wave front. Then third crest of first wave, third crest of second wave, third crest of third wave. When I join, I will call that as a wave front. So wave, there's a difference between wave front and wave. Wave here refers to like single, but wave fronts are representing when many waves are there moving together from one place to another, and we represent the identical points. So what we call these identical points, we call these identical points as wave front. Is it clear, the definition of wave front? The lines which represent identical points of different waves. What will be the difference? What will be the, what we call the distance between the two successive wave front? What we call this distance? Distance between the two successive crests. So distance between the two successive crests is wavelength. So distance between the two successive wavefront is also known as wavelength. Take the screenshot of this and I'll start the topic. This is just an introduction, like what is a ripple tank, and now we'll discuss the properties of the waves. What is a wavefront? There's a wavefront represent identical points of the different waves. From wavefront, you cannot count the frequency. For that, you should know the time. Like example, say this is a source. Say this is a bulb or a lamp. Light is transverse. Transverse means the vibration is perpendicular. So this is one light wave. Then this is another light wave. But for light waves, because we cannot see the wave, so that's why we cannot say the wave front easily or identify the wave front. But for water, because it is easy to observe and produce, that's why we use water to study the properties of the wave. So you can see this is crest of one wave, crest of second wave, crest of third wave, and crest of fourth wave. So when I join these crests together by a line, what I will call this line, I will call this line as a, this line is known as wave front. When I join another crest, not the troughs, identical points always. Now another crest of first wave, second crest of second wave, second crest of third wave, and second crest of fourth wave. So when I join them by a line, it's not necessary it is always straight, it can be curved as well, depending on the position of the wave. When I join the third crest, when I join the fourth crest, so all are known as a wave front. And the distance between the two successive, the distance between the two successive wave front, that is known as wave length. What we can do with the wave fronts are easy way to explain the wave, like the movement of the wave. Example, if I say I have a source, a large source is there, so and it is emitting out lot of waves, giving out lot of waves. It will be difficult to draw all the waves together. So instead of drawing the waves, what we can do, we can draw the wave fronts, which is easy thing to do. And the direction of the wave is always perpendicular to direction of the wave front. You can see these are the wave front, but what is the direction of the wave? The direction of wave is 90 degree or perpendicular. If you have a large source, if you have a large source, it will produce a plane wavefront or flat wavefront. And if you have a small source, it will produce circular wavefront. So example, say same example, a ripple tank. You have a ripple tank, and this is a top view, like you're looking from the top for both cases. I use a large object, this large object, and here I use a small object. So when I produce a disturbance in the on the water surface, it will produce a wavefront. But what will be the wavefronts? The wavefronts will be plane or flat wavefront. And the direction of the wavefront, direction of the wave is always perpendicular to direction of the wavefront. Here, if I drop an object or I move this small object, so what I will see, example, if this object I place it exactly at the center, it can be near the edge also, but if I'm placing at the center, and disturb the water surface, so what pattern I will observe, the wavefronts, spherical wavefront or circular wavefront, and the direction of the actually what it shows the wave is actually traveling in all the directions from the source. But here the wave is actually traveling in a particular direction. Is it clear, the concept of wave fronts? So instead of drawing the wave, we prefer to draw the wave front because it is easy to represent the waves. Any doubt in this part, the wave front? Take the screenshot for
Sir, I
this.
have a question.
Yes.
Sir, why do large sources produce like waves in one direction while like small sources produce circular waves in all directions?
No,
Why
because
won't the wave go up,
yeah,
for
wave will
example?
go up, but the thing is, for when you compare the size, like your question is why a small source is producing wave in all the direction, but for a spherical for a large object is in a particular direction. When we disturb, it will produce a wave in all the direction, but you can see there is no space for the wave to travel in this way. It will produce waves sideways, but these waves are not able to travel. So we
So
can
they're unimportant.
yeah, because like example, say this is a ripple tank and you have a very large object and you disturb, so even it will produce wave in this direction, it will produce wave in the left hand, downward and right, but because there is no space for the wave to travel, only space which is available for the wave to travel is towards right hand side. So that's why I drew only towards the right hand side. Practically it will produce wave in all the direction, but specifically because that can be neglected, so we are saying that the wave travel from one place to another. Is it clear now?
Yeah, okay.
So the ripple tank, now we'll show the ripple tank. So ripple tank, it's a shallow glass bottom tank is there, which contain a small amount of water and the light source is there in front of top of this. You can see this is a oscillating paddle is there. Oscillating paddle means this paddle will move up and down. So when this paddle is moving up and down, you can see the pattern. These are not the waves, these are the wave fronts. And instead of we place a light source, so we can see a shadow at the bottom. The light, so this shadow can also be used to measure the wavelength of the wave which we are producing. This is how actually the ripple tanks look like. This is the original picture of a ripple tank. A transparent glass is there, a shallow tank which is filled with water. So if we use, you can see we can use a small spherical object. So if we use a spherical object, the wave pattern will be like this, the wave fronts. But if we use a large object, then it will produce plane wave fronts. This is also another picture for this ripple tank. You can see a support which is producing a vibration. How it is going to make a wave? What happened? This is filled with water. So if you have a water and you disturb the surface of the water, like this is a container tank, and this tank is filled with water. Now, if you take a small object or a large object and you move the object up and down, so when you move this object, so basically you're disturbing the water surface. So as you disturb the water surface, what it will produce? It will produce the waves. But what you observe here, these are not the waves, these are the wave fronts. Like many waves are together moving in one direction. So you see identical points of the wave and you call that as wave front. This is a kind of pattern which you can observe. Same thing, like if you take a spherical object, small object, So ripples, again, what are these? This is a shadow. Like you have a source here, a light source is here, and you're observing a shadow. If I take a small spherical object and I produce a vibration up and down for these spherical objects, so these spherical objects produce a wave fronts. Waves or wave fronts will be there. So what pattern I will see? I will see a pattern like this. So what it shows that waves are traveling towards right, waves are moving towards, means top side, down, left, towards right, towards left, in all the direction it is traveling. But instead of the wave, you will see, you will observe the wave front. So the first property of the wave is a reflection. What is the meaning of a reflection? Reflection means property of a wave to change the direction when it hit the surface. Like wave hit the surface or strike the surface and it changes its direction. What we call this property as reflection. So to observe this, what we can do to observe the reflection, here is a ripple tank. This is, say example, a side view, and you place an object here, a large object, and this is, and you're producing a disturbance. So when you produce a disturbance up and down, it will produce wave. So wave, as it produce, it will move towards the surface, strike the surface and bounce back. So this property of a wave to strike the surface and bounce back, what we call that as reflection. But this is when you're looking from the sideways. Sideways, it is not easy to observe reflection. When you're looking from the top, a top view, and example, you produce, this is an object, a reflecting surface, and you produce a wave. Say you produce a plane wavefront. So when these wavefronts strike the surface, they will bounce back, and what we call this as reflection. So property of the wave to change the direction when it strikes the surface is refers to reflection of the wave. Like you can see there's a barrier, and these are the wave fronts which are striking the surface. So the wave fronts which are striking a surface, and then after striking a surface, they changes the direction and bounce back. So this property, these are wave fronts, not the wave, because what's the meaning of wave front? Means they are representing means there are a lot of waves moving towards the surface, but instead of drawing all the waves, what we do, we draw the wave fronts. So the wave which is striking the surface is called incident. The wave which bounce back is known as reflected. And always the angle of incidence is equals to angle of reflection. Barrier or the surface they strike, they bounce back. Is it clear? The wave which striking a surface, these are called incident. Any doubt in reflection? And the wave, the waves will bounce back because of wall of the container. That's also true. And this is these are the properties of the wave. So this happen for all kind of wave. This happen for light waves, also reflection occur. Sound waves, reflection occur. Electromagnetic waves, reflection also occur. This can happen for with a this happened with a barrier as well, the walls of the container. So if we have a ripple tank and we are producing a wave, here we are producing a wave. So the wave which strike, that's called incident. After striking a barrier, the container wall, the waves will bounce back. That is known as a reflected one. But if it is making certain angle, if waves are making certain angle, the direction of the wave is always perpendicular to direction of the wave. So if wave fronts are given, this is the direction of the wave. When example it strike the barrier, it strike the wall of the container, it can also bounce back, and the wave front, the wave which bounce back, that is known as reflected. So during a reflection, the only thing which changes is the direction. The wavelength, the speed, the frequency all remain unchanged. The only thing which changes is the direction in which the wave travels during a reflection. So exam style questions you will find in exam question related to reflection. What normally they ask, they will give you a reflecting surface. This is always done with measurement. So they will provide or give you a reflecting surface and the wavefronts will be shown, given to you. Now the question will be complete the diagram to show reflection of the wave. So how you'll complete this diagram? First, you will draw the direction of the wave. How to draw the direction of the wave? These are the wavefronts, so direction of the wave is always 90 degree. So first you will draw the direction of the wave and you call that as incident wave. That's first thing. Then imaginary line which is perpendicular to the surface. This imaginary line perpendicular to the surface, that line is known as normal. The angle between the incident and the normal is known as angle of incidence. So example, if this angle of incidence is say 60 degrees, so angle of for a reflection to occur, the angle of incidence should be equal to angle of reflection. This is also called law of reflection. When something is a law, it means it is coming out through all the time. It's not a theory, it's a law. So it's true for all the cases. So angle of incidence is 60. So what you have to do, you have to measure this angle, because the normal you will draw and using a protractor, you will measure this angle and place a protractor and draw 60 degree for angle of reflection. Angle of reflection should also be 60, and then draw the wave fronts. The distance, keep in mind, the distance, this distance, which is wavelength, should be equal to other distance. That's also wavelength. So only the direction changes, and this one is a reflected wavefront. Is it clear how you'll complete the figure to show a reflection of the wavefronts? Normal line will not be given to you. Normal you have to draw. And what is a normal? The normal line is always 90 degree or perpendicular to the surface. So another example, if I say this is a reflecting surface and the wavefronts, normal line you have to draw, it will not be drawn with the figure. So if these are the incident wavefronts, so first you will draw direction. Then 90 degree to the surface. So this is a surface, 90 degree to this surface. we'll draw a normal. And always use thin lines, because if you use thick lines, then angles will not be accurate. So if this angle was 30 degrees, the light would strike or bounce back. So angle of reflection will also be 30 degrees. So the normal you have to draw. The only thing which will be given to you is the wave front and the reflecting surface. So property of a wave to change the direction when it strikes the surface, we call that as reflection. This question can be in multiple choice question paper 2. If it is in paper 2, then different figures will be there and you have to select a correct direction for the reflection. If it's in paper 4, then you have to complete. Normally what the pattern which I explained just now, it is related to paper 4, because in paper 2 choices are there, so they will show you the figure and ask which one is showing the correct direction for reflection of the wave. The second property is called refraction. What is the meaning of a refraction? Refraction means property of the wave to change speed and wavelength when traveling from one medium to another. So when the wave travels from one medium to another, the wave changes its speed and its wavelength, and we call this property as refraction. So example, for water waves, what kind of medium, because water is one medium, how we can create two mediums in water? So this is a ripple tank. A ripple tank is filled with water. So right now it's one medium because there is constant density throughout. But if we place an object inside this tank, so we create two regions. One is a deep, another one is shallow. So in deep region, the particles, because they have more space, so compared to shallow region, the particles are relatively far away from each other. In a shallow region, because of small space is available, so particles are relatively closer to each other. So which water you think is having high density, deep or shallow? Which water is having a high density, deep water or shallow water? A shallow water is having a high density because density is mass over volume. So shallow water is having a high density. And deep water is having a low density. Comparatively, it's like a comparison, very small difference will be there, but when we compare, because small space is available, so particles are relatively closer in a shallow region as compared to deep region. So when we produce the water waves, what we observe, if I produce a disturbance at this point and move this object up and down, So it produces a wave. But what we observe in a deep region, the water is traveling faster. But moment it enter a shallow region, it slow down because shallow region is not allowing the water waves to pass easily, not able to transfer energy quickly. So what pattern we observe in a deep region? We observe the waves are far away from each other, but as they enter in a shallow region, so the as it enter in the shallow region, we observe that the waves come closer to each other. So which region is having a greater wavelength, deep or shallow? So in a so moving from deep to shallow, so as the water waves are moving from deep to shallow, what we will observe? We'll observe that the wavelength decrease and speed decreases. And you can observe this like if you are standing at a seashore, at a coastal area, and you're observing the waves. So as the waves are approaching the seashore or the coastal area, you will find that the two waves, when they're far away from you, there is a greater gap distance between them. But as it reaches the shore, which is a shallow region, so what you will observe? You will observe that the wave fronts or waves come closer to each other. So this property of a wave to travel from one medium to another and change its wavelength and speed, we call this property as refraction. Why this happen? Because of difference in the density. Deep region is having more density, shallow region is having high density. So because of the difference in the density, the speed and the wavelength changes for the wave, and we call that as refraction. But what about the frequency? The frequency does not change when it travels from deep to shallow. Why the frequency does not change? Look, for example, a wave was having a speed of 10 meter per second and wavelength is equals to 5 meter. So when I find the frequency, v is equals to f lambda, or frequency is speed divided by wavelength. So speed is 10, wavelength is 5, so 10 divided by 5 will get frequency 2 hertz. But when it enter a shallow region, speed decreases, maybe speed is 6 meter per second. Wavelength also decreases, wavelength is now 3 meter. But when I calculate the frequency, the ratio between the frequency and speed and the wavelength does not change. Both decreases, but the ratio remains same. And the ratio between speed and the wavelength is called frequency. So the frequency remain unchanged. So whenever wave travel from deep to shallow, it does not, it changes its speed, it changes its wavelength, but it does not change the frequency. The number of wave, it's not according to time scale. That's why looking at this figure, maybe it appear like looking at this figure, it appear that these two waves are closer and these waves are far. But what happened? The number of waves per second, the number of the waves per second does not change. That's why the frequency remain unchanged. Is it clear? This part, moving from deep to shallow, the speed decreases, the wavelength decreases, but the frequency remain unchanged.